All right, hello everyone. Welcome to another CData Coffee Break webinar. My name is Matt Springfield. I'm a product specialist here at CData, and today we're talking about EDI translation and mapping. If you're not familiar with our Coffee Break series, these are intended to be short presentations so you can enjoy a cup of coffee and hopefully I'll be done before you are. And there's an emphasis on the live demo, so we'll be jumping into a live demo in just a few moments. First, just a quick few words about our company, CData. CData is a data connectivity company. Today we're talking about B2B connectivity with EDI translation, but CData does more than just that. Real-time access to your data in your ecosystem no matter where you want to work with it, data replication, cloud data connectivity as a data virtualization layer, and more. But today we're focusing on CData Arc, part of the CData portfolio, and this is our solution that provides no-code end-to-end B2B automation. So each of the steps required for that fully end-to-end B2B automation are that secure managed file transfer to talk to your partners, EDI translation and mapping. Of course, we're focusing on that today. Backend integration, so you can talk to your databases and applications and so on. And then business logic and routing to help glue everything together. So EDI integration, as many of you know, is a good chunk of the work involved when you're trying to integrate with your trading partners. And so we want to simplify that. So how does CData Arc simplify EDI integration and mapping? The primary way is through our drag and drop mapping designer. So this is our tool in CData Arc that provides this no-code data transformation for EDI, other data formats too, but we'll focus on EDI. And we first automatically model all of your data, including EDI data, as XML. So you don't have to do this yourself. This is something Arc does. But once it's modeled as XML, that allows you to simply drag and drop elements between the source XML and the destination XML to create a mapping relationship. We'll also dig into some of the more advanced features like the expression editor. This allows you to not just map values, but also format or manipulate those values as they're being mapped. And then finally, we'll touch on some conditional logic for your mappings that require a little bit of intelligence to determine what should appear in the output. So the highlights for today, just real quickly before we jump in, the simplicity part. So drag and drop is the core of what we do for EDI mapping. And there's two ways that you drag and drop to map in CData Arc. We have for each loops for repeated data structures to make sure that you're capturing all of the data in your documents. And we have value mappings. That's, of course, the beating heart of data mapping is making sure the values in your document end up where you need it in your destination. But in addition to the simplicity, there is also power here. And we're going to show this off with the expression editor, which allows you to do more powerful things like format values. Frequently, dates need to be formatted. Perform arithmetic and other operations on your data during the mapping. And we're going to touch on lookahead conditional logic. So this is a type of conditional logic that's really more easy to explain with an example. So we'll talk more about that when it comes up in the demo. And speaking of the demo, that's enough talking in this short presentation. Let's jump right into CData Arc. So here I am in CData Arc. If you haven't seen it before, this is our workflow canvas where we build automated B2B workflows using these connectors here on the left and connect it together to create automation flows. So today's example is going to be integrating an EDI 850 purchase order into a SQL Server backend. Now, we're going to be focusing mostly on the EDI mapping part, and the EDI mapping principles are the same no matter what document and backend you're using, so don't worry if you're not using an 850 or if you're not using SQL Server, the same principles will apply. We just need an example to get started. So to get started, I'm going to drag the connectors we need for this example. There's going to be the X12 connector for our X12 document, that is the EDI 850. And in addition to our X12 connector, I'm going to need our backend connector, which is SQL Server in this example. And again, this is not example specific. We just need something to kick things off. So here we go. And actually, before I connect to my SQL Server instance, let's get the third connector that we need in here, which will tie these two together, which is the XML map connector. If you're not familiar, the XML map connector is our workhorse data transformation connector in CData Arc. So we're going to spend most of the time in this demo here in this connector. And you can see that there is a visual designer here with our source and destination that is currently blank. And the first thing that we want to do is fill in the source and the destination with some templates. I mentioned that data gets modeled as XML to use as templates in Arc. So let's see what that process looks like. So we'll start with the EDI document. We're going to model our EDI document, which is again 850 as XML. And I'll go ahead and connect these connectors as well, since we'll need that ultimately. And we can see that just by connecting the X12 connector, we already have a bunch of document-specific templates. So, if I wanted a 204 document as my source model, then I can just go ahead and select that. But these are fairly generic models. After all, We're just using sort of the definition of an EDI 204 document to build that schema. If we want to get more specific, more granular, then we can upload a sample EDI file, to create a schema out of that. So let's do that now. We'll upload a test file here that's going to get modeled as XML for our templates while mapping. So we've got this R850 EDI document, and so we've now just created a template out of it just by selecting that upload. And I am going to show it to you here. If you haven't seen EDI before, this is going to be a little obtuse, but this is our EDI document. We are actually working with real EDI data. This is an 850 purchase order. As you can see, I'm buying a PlayStation and some controllers. That's me, Matt Springfield. So I'm very excited to purchase these things. But yeah, so this is the example purchase order we're working with here in our EDI format, and we just used it, uploaded it as a template. All right, next we need to template the output, the destination, which is our SQL Server tables. So I'll select a SQL Server connection here to get started. This is just a simple set of connection string properties like a username, password, server, port, that kind of stuff. And I've already configured that connection just to save some time. And so I've selected that pre-configured connection here, but it's just connecting to SQL Server on my local machine, a very simple test instance. So right now we've just confirmed that I can talk to my local SQL Server instance as a test. The next thing to consider here is our action. Action is the way that we're going to interact with SQL Server in this case. And as you can see, it's set to upsert. Upsert is just a combination of update and insert. If you're familiar with database terminology, you'll know that that means we're pushing data into SQL Server. So we'll keep that action as upsert so we can insert our EDI data into SQL Server. The last step is to choose what data objects or tables, in this case, we're interested in working with. And if I hit this add button here, we can add a new table, and it's going to dynamically read the available tables from SQL Server. And we can see there's not very many tables in my test SQL Server instance. It's just for simple examples, but we know that we want to connect to the purchase orders table. After all, we are receiving 850 purchase orders. But if I know anything about purchase orders, I will also know I don't just want to talk to the purchase orders table. I also want to connect to the line items table, because purchase orders contain line items. Line items are the individual items you're purchasing, of course, in a purchase order. And in order to capture the data from this EDI document, I want to insert data both from the purchase order itself and from the line items within that purchase order into SQL Server at the same time. So with that, we've actually already templated both our source and our destination. The source with that example 850 EDI file I showed you, and the destination template is going to come from those two tables I just connected to in SQL Server, but I do need to select from that list what our source template is going to be, and we'll just go ahead and select that R850 document that we uploaded as our example. And as soon as we have both these templates set, which again were generated by Arc, we can see the visual designer, the mapping designer, is populated with an XML model of both our source and our destination. And the point here is I didn't need to do any work to create these models. I just needed to upload my EDI file and know which tables I'm working with in SQL Server, and Arc can build these templates itself. So now the task is to drag and drop the data that represents our EDI on the left onto the structure that represents our SQL Server tables here on the right, and that will create that mapping relationship. Now I mentioned that the first way that we use drag and drop is to create for each loops that handle repeated data structures in your source, like your EDI document. Well, I know that my purchase order document might contain multiple purchase orders, and I know that the TX element represents a purchase order in my data. So to make sure that each of my TXs, each of my purchase orders, ends up in SQL Server, I'll drag and drop this TX element onto purchase orders to create this for each relationship. But that's not the only possibility of repeated data in my EDI document. I'm also likely to have multiple line items in each purchase order. After all, in this example, we saw that the purchase order contains two line items, both the PlayStation and PlayStation controllers. So I need a second for each relationship in my mapping to handle the possibility of repeated line items. And I know that the PO1 loop 1 element segment contains my line item data in my EDI, so I can drag and drop the PO1 loop 1 onto line items to create this second for each relationship in the mapping. So now we know that for every purchase order in the document and for every line item in each purchase order, we're going to be able to map and capture all of that data. So that's the first drag and drop mechanism here, is for each loops to capture repeated data structures in your EDI document that will repeat a variable number of times. The second mechanism for dragging and dropping is mapping actual values from your source onto your destination. And at this point you might ask, well, how did Arc know to create a for each relationship instead of map values when I dragged and dropped? And the answer is it depends on the type of element you're dragging from the source. So you can see how this BEG element is expandable and contractible, and it has children elements that have values. The fact that the BEG segment is expandable and has children makes it a parent element. It doesn't have a value, it's just a parent to other elements that might have values. And it's when you drag and drop a parent element, like this TX, that Arc will create a for each relationship. After all, these parent elements don't have values, so Arc knows that what you want here is a for each to capture repetition. But now we'll move on to elements that do have values and don't have any children, so we call these leaf elements. When you drag and drop a leaf element, it'll just take the value from that element in the source and insert it into the element in the destination. So let's say I want the PO number. It's a pretty important value to have in this mapping. So I can drag and drop the BEG03 element. That's the element that contains my purchase order. I can see the test value here to confirm my suspicions. And if I just drag and drop it over here, it creates this mapping relationship. It's reading the value from this path in the document to populate the PO number when it inserts into SQL Server. And you can continue mapping other values like this. This is a very simple principle. So the currency code and other values like that. So at this point, we can recognize that the mapping process is just a simple matter of knowing what elements might repeat, like the TX for purchase orders or the PO1 loop 1 for line items, and then knowing what elements contain what values, like the BEG03 containing the purchase order number. So that captures the simplicity of EDI mapping in Arc, handled primarily through dragging and dropping. But let's use the expression editor now to do something more sophisticated. And as the first example, let's consider mapping this PO date. Well, I know that it's here in BEG05, but we have a problem. The format of this date isn't the format that our SQL Server instance expects, so we'll need to format that date as we're mapping it. We can do that with the expression editor, so I'll hit this button to open the expression editor. So we have a large set of formatters, I'm not going to scroll through them all, that help manipulate and format data as we're mapping it. The one that we're interested in is called toDate, so I can search for that, and this helps us format and create dates. If there's a little blurb that helps document this, it is more comprehensively documented in our documentation proper, in case this looks a little bit terse. Okay, to use this formatter, the first thing I'm going to do is add a vertical pipe character here in the expression. This means take the value from the input document, BEG05, it's the date, and pipe it into a formatter, input it into a formatter. So I can then click the formatter toDate to add it to the expression, and we need to give it a few parameters. So first we give it the output parameter, so let's say I want the 4-digit year, and then month, and then day. Then optionally I can give it the input format for the date, in case Arc is having trouble detecting what the format is, and I believe in my example it's month, day, and then the 4-digit year. So this is saying take the date from the document, but then turn it into this format as you're mapping it. So now you can see in the mapping that we're mapping the value and also formatting it at the same time. Okay, so that's one example of using the expression editor to format a value, but let's do something slightly more advanced. So let's say we want to perform some arithmetic or an operation on our data. A good example of this occurs in the line items data of a purchase order. So I'll scroll down to the line items. I know the line items are here in PO1 loop 1, so I can expand that. And yeah, as you can see, this is the PlayStation console line item. And I can start just by mapping a few simple values here. So we've got the item name. This is leaning on the simplicity idea. This is how we get data from the line items in our EDI into SQL Server. And then I can drag and drop the price in PO104 and the quantity in PO102. And then the issue that we run into is here in item total. So I know intuitively that item total is just the price times the quantity, but that value doesn't appear in the EDI document. So there's nothing I can drag and drop to populate item total, even though I know how to calculate it. What I want to do is perform a multiplication between the price and the quantity, and I can do that with the expression editor. So to do that, I'll start with one of the values involved, which in this case, let's say the quantity in PO102. And once I have that, I can open up the expression editor and perform this arithmetic operation. So I'll start as usual with a vertical pipe saying input this value into a new formatter. Then I'll find the formatter that I want, which in this case is multiply. And since I'm multiplying this with another value from the document, I have another variable, so to speak. So to capture that new variable, I'll add another set of square brackets. Then I can head back to the Dynamic Content tab. Dynamic content is all of the elements from our source. You can see these are all like PO1 elements that's in the context of our mapping. So I know that the element that I want to add to this expression that I want to multiply the quantity by is the price. So if I find the price in this list of dynamic content, I can just click on it, it's PO104, to add it to the equation. And now the expression reads, to find the item total, multiply the item quantity times the item price. And there's a few other values that we could map here related to line items. One thing that I don't want to forget is this PO number. You can see that's shared both with the purchase order and the line items. They both reference the same PO number. And since that's an important foreign key relationship, I want to make sure I don't forget that in the mapping when we try to actually test this flow. Now we can move to our final example of using the expression editor to add lookaheads. Lookaheads are a type of conditional logic in the mapping. And I mentioned they're best explained with an example, so let's use the example of these three shipping values, the shipping city, street, and zip. Well, I know this information is going to come from the in1 loop 1 segments in my EDI document. These in1 loop 1s contain information for each party in an exchange. So things like the ship to party, the bill to party, the remit to party, and so on. The issue is that I have multiple of these in1 loop 1s in my source. So this one is me, the second one is my colleague Ron, and only one of these is the ship to party. I want to make sure if there's multiple parties involved that I'm getting the shipping address for the ship to party, not just any party at all. So to accomplish that, I'm going to start by mapping the value as if I know already. So we can see, the street address for one of these is 101 Europa Drive, and we can go ahead and map that. But now I want to add the actual conditional logic that says only map that value if we're talking about the ship to party. So to do that, we'll open up the expression editor again. So inside the expression editor, I can add a lookahead clause. The reason it's called a lookahead is you're looking into some other part of the document, you're looking ahead to see if this is the right part of the document that you want to be mapping, if this is the right in1 loop 1. So the way that we know that an in1 loop 1 contains the ship to party is with this st value here in in101. So this is appearing in in1 loop 1, in1, in101, and it's indicating this is the ship to party. You notice the other one has bt in in101, identifying it as the bill to party. Now what makes it tricky is we're not trying to map the actual in101. We're not mapping st or bt. We're mapping the street address. We just want to make sure that it's the right street address, the st street address for the shipping street. So here's the logic that we can implement here in the expression editor. So we want to map the in301, so this is looking good, but we only want to do that if the in1 in101 is equal to st. So I can add that clause here. So now we've got map the street address, but only in the in1 loop 1 where in1 in101 is equal to st. So we can see this conditional logic now showing up in the mapping. And we can continue doing this with some of the other shipping values like the shipping city. So this is taking the city, which is here in 401, but we only want to map the city, the shipping city, if our in1 in 101 is equal to st. So once again, we've got the value that we're mapping and then a look ahead clause to make sure it's the right one. And then last example, the shipping zip in 403 this time, and we'll add that same clause. We want in1 in 101 to be st. So if I've done everything right, then we can read these mapping values as we're going to look ahead into the in1 in 101 value to make sure we're talking about the ship to party before we map the values like the city and the street and the zip. So with all this, we've guaranteed that we have the right value even despite our repeated in1 loop 1 segments. So you could do the same process with the billing values, the billing city, billing street, billing zip. Map these and then add the conditionals in the expression editor to make sure that we're getting the right values from the billing party this time instead of the shipping party. But to save time, I won't actually go through each of these. Hopefully you can see how the same principles would be applied. So I'll do a once over of this mapping, and then once I'm satisfied, we can come up and save this mapping. So it's time to actually test our EDI integration flow. Just to prove to you that I'm not hacking this, I will show you my local SQL Server instance, a very simple test instance. This is SQL Server Management Studio. Don't worry if you haven't seen it before. I'm just executing a simple select query to prove to you that the purchase orders table is currently empty. And then I can do the same thing with the line items table, so you can see there's nothing in here. But we're going to integrate that 850 document into these tables so you can see that data is actually moving. So back here in Arc, we can kick off this flow. I'll go to the X12 connector and upload our test EDI document that we're working with here in the Input tab. Now, before I actually upload this and kick off the flow, I'll mention we are expecting to see a warning here, and the reason it's going to be a warning is I didn't actually configure this EDI connector with the sender and receiver identifiers, so the connector isn't able to verify that this is coming from the party that it expects to be coming from. So it's going to warn us about that, but it is still going to process the file. And we can go into the XML map and see that the mapping has succeeded, so that's great. And then finally, we can go down to our SQL Server connector and check to see that that file has in fact successfully been inserted into SQL Server. So let's take another look here in SQL Server Management Studio. We can run those same select queries, and here you can see there's a new purchase order in our purchase orders table. As you can see, it's me. I'm at 101 Europa Drive. We don't have the billing information because, again, we skipped that for the purposes of time, but we can see the shipping information came through using those lookahead conditionals, and the PO date is formatted as we expect, so all this looks good. And then if we look at the line items and run this query, and there we go. So we can see that PlayStation console and the controllers. So we've got all of our data associated with that purchase order. So here's the purchase order again. We've got all this EDI data now integrated here in SQL Server. Hopefully that's clear. I just did this live. You saw me create these connectors and do the work in about 15 minutes, taking a real EDI purchase order and integrating it into admittedly a very simple SQL Server table. But hopefully this shows how the XML map connector really simplifies the process of these EDI integrations, first with the automatic generation of templates, then with the simplicity of drag and drop for each and value mappings, and then the expression editor to add additional powerful formatters and operations and conditional logic. And that wraps up the demo for today. Hopefully it gave you a sense of EDI integration in Arc. If any of this looked particularly interesting to you, you'd like to learn more, you can always read about us at arc.cdata.com. We do have a free trial in case you suspect maybe it's not quite as simple as I've led on in this presentation. I encourage you to get your hands on it yourself. No need for a credit card or a call with us before you start playing around with Arc directly. You can find out more about that at arc.cdata.com/trial. And then finally, if you have any questions you would like personal answers to, then sales@cdata.com is a great resource. Even if that team is not prepared to answer your question, they'll make sure to route it to the professionals who can. So thanks once again for joining me today. I hope that you've learned something. I hope that your coffee has been great, and hope to see you in the next CData Coffee Break webinar.